volume of a prism. We established this is a prism, correct? Who remembers in year like 2 and 3 when you were counting and you were learning about ones, tens, hundreds? How do they do that? What do they give you? Little wooden blocks, little counting blocks, and 10 ones would equal a 10 and 100 ones would equal 100, and they'd come in the blocks, correct? If I had measured this correctly, which I haven't, but this is my prism. And my question to you is simply, how many of those little 1 by 1 by 1 centimetre blocks could I fit in this? I want you to think of an answer. I'm going to give you 10 seconds. So it's 6 centimetres across, 5 centimetres, or 5 across, 6 up, and 10 back. Mason, what do you think?
300.
Mason says 300. Very good. So this is 1 by 1 by 1. That's 1 centimetre by 1 centimetre, which makes it 1 centimetre by 1 centimetre, 1 centimetre, which is 300 centimetres cubed. Very good. I should have my units. Does anyone else have a different response? So every single person in this room says I can fit 300 of those in. We're all agreeing or not? In reality, could I fit 300 in there? Probably not. I'd have to push pretty hard, maybe cut out a top. But hypothetically, I could fit 300 in there. How do you know? Not one person needed to put stuff in this to figure that out. How do you know? How does every single student in the room know? Riley?
Seeing as what we're putting in is 1 centimetre cubed.
Yep.
That means it takes up 1 centimetre space.
So you're saying that, let's just go through the bottom row. Let's say I put my first 5 in. If I put them on the bottom there, 1, 2, I should make them bigger because my 1, 2, 3, 4, 5. Are you saying that that would be appropriate? How many times could I do that vertically?
6 times.
I could do that 6 times, so I can go 1, 2, that's 4, 3, 4, 5, 6. So that would be one lot of that. How far back would that extend?
10 centimetres.
For the first row, it would go 1 centimetre though, wouldn't it?
Yeah.
Like so. And I could do that how many times? 9 other times, which is 10 in total. Very good. Okay, I'm not going to draw that because we know how that's going to end. It's not going to end well. Is there a faster way of doing that? Gabby? So Gabby says volume equals length times width from height. I think she's 100% correct. Let's change this though. Let's change this. It's no longer this shape. I don't want to fit it in that anymore. I want to fit it in a cylinder. Now let's say you know I've got a 10 centimetres long cylinder and I can fit on the face, I can fit 15 centimetres squared worth of material. 15 centimetres squared worth of these little blocks. What's the total volume? What's the total amount of these cubes I could shove in? What's the total volume?
Would it be 150 centimetres cubed?
Harry says 150 centimetres cubed. Who agrees with Harry? Who disagrees with Harry? I have fit 15 of these in the first row, and he says I can get 150 of them in. Does everyone agree with Harry or not? Sorry. He said 150. How'd you do it, Harry?
I said 15 times.
So he said...
The surface area times the height.
Oh, he said area times the height. I would argue that you've done exactly the same thing that Gabby has done. How can I make that argument? Area is length times width. So I could give you an equation for every single prism. A circular cylinder, a triangular prism, a trapezium prism. I'll give you all those things. Or I could give you one equation. What's the one equation I could give you? The volume of a prism equals...
Sorry, times height.
Does it have to be height? What if I turn it on on its side? Could I find the area of that prism? If it was 10 by 10, what's the area? That's 10 centimetres squared by 10 centimetres. What's the area?
20 centimeters squared.
Does it matter it's length now, not height? So you don't need to know that it's height or length. You just need to know that that's the distance it's being pushed back, or up or down. Cool? I'm going to leave it as area times height, but don't worry about whether it's height or length or width. Cool? So that's the area of, that's the volume of our prism.